nothing is canned and said as you see it. There's always a surprise. So today I'm going to talk to you briefly about manhole rehabilitation. As Jim said, I'd like to thank Vicky, Kelly, and Jim and Lindsay at Twitches Technology for putting on this wonderful event. And very importantly, I'd like to thank all the participants for joining us today. Without you, this event wouldn't take place, and I'm very excited that I can hopefully share some valuable information with you on this call today. So as I mentioned, manhole rehabilitation, we're going to be talking today about using the appropriate rehabilitation system because one solution does not fit all. Okay, so I'm going to give you a brief outline now. If we can flip to slide number 2, please. I'm going to tell you a little bit about Epoxy Tech. I'm going to give you some background, pertinent perspective information about the industry and why it is we're discussing today. I'm going to then talk to you about some of the typical generic rehabilitation options that I'm sure most of you are familiar with or have come across at some point. And then we'll look at some of the factors that you need to consider when determining the right system or the right solution for rehabilitation. And we'll look at the different systems. At Epoxy Tech, we came up with what we thought were 4 systems that help you meet most of these criteria. And then we will take a short Q&A to take any questions regarding any of the material that we've discussed. So, without further ado, I'm going to tell you a little bit about Epoxy Tech. Our vision is to be a highly respected, globally recognized brand of coating and repair solutions which extend the life of physical infrastructure. The emphasis here is extending the life of physical infrastructure. Our goal is to help folks like you that own the infrastructure, work on the infrastructure, and engineer specifications for maintenance of this infrastructure to extend its physical life. Our mission is to have a portfolio of high-performance product solutions which repair, protect, and maintain physical infrastructure. Again, the focus on physical infrastructure. These solutions are the most cost-effective for the long term, consistently delivered with a high level of service. And the emphasis here again, folks, is the most cost-effective for the long term. We're not always out there to sell the cheapest system available. Even if it's available, what we want to do is make sure that long term you get the most cost-effective solution for your rehabilitation project to extend the life of your physical infrastructure. We have been in business for over 30 years. We have experience in this industry, particularly in wastewater infrastructure, rehab, maintenance, and repair for over 3 decades. In fact, we have coated over 3 million square feet of sewer infrastructure at Miami-Dade Water and Sewer alone. And that doesn't account for all the other structures we have now been working on in the past couple of years nationwide. So I'd like to scroll forward now that I've told you a little bit about us, and ask you one simple poll question. Does your municipality's wastewater collection system currently have any manholes that require rehabilitation attention? Answers are fairly simple. It's either yes, no, or in case of perhaps an engineer, not applicable in this case. Thank you. And now can we move on to give you a little bit of pertinent background that I think will help put this presentation a little more in perspective. The sewer systems in the United States are between 30 and 100 years old. And most of you are shaking your heads and thinking, yeah, close to 100 years, I know. The average is supposed to be 50 years plus. And that obviously is the problem. Most of these systems have been designed for a 30 to 40 year lifespan. And most of them, as you probably know, are way beyond that original design life. Manholes themselves, which we're focusing on a little today, can be identified as the single highest contributor of inflow and infiltration in the wastewater infrastructure. There's a lot of debate about this, but there's no question they are amongst the highest. Somewhere in the vicinity of between 30 and 60%, depending on which statistic you quote. would 30 to 60% of inflow and infiltration is actually caused at the source of a manhole. Manholes, however, are the simplest and cheapest way to cut down on infiltration, and therefore we have an opportunity here. By far the biggest bang for your buck can be spent on rehabilitating your manholes. And the simply put, if you want to save the capacity, maintenance, and expansion cycle of the most complex and expensive part of your wastewater infrastructure, namely your wastewater treatment plant, you can do this by simply investing smaller amounts of money in the infrastructure, which is the simplest out there, namely your manholes and manhole rehabilitation. Okay, let's move along. Let's briefly look at the types of corrosion that we experience in the wastewater infrastructure system. As I mentioned, inflow and infiltration is a big one. A lot of people want to rehabilitate manholes for the simple reason that they have major inflow and infiltration. When we talk about inflow and infiltration, it's affected by sea tides if you live near an ocean or lake. It's affected by the amount of rain you have, groundwater. All of these items cause hydrostatic pressure to be placed on the outer structure of the manhole. Manholes are typically made of brick or concrete, which as we all know is porous, and over time this water works its way through into the structure, which essentially gets fed down to your wastewater processing plant, majorly increasing the capacity that has to be processed. And over time what it actually also does is it deteriorates the structure because it breaks down the concrete as it comes through it, or the brick in that case. The second one is hydrogen sulphide. These are the gases that are emitted from the wastewater that cause bacterial buildup inside the porous concrete. Now folks, we all know any concrete you use is still porous. It's like a sponge, so bacteria harbors itself inside the coating or inside the concrete and causes sulfuric acid buildup, which essentially deteriorates the concrete, causing the structure to become compromised. And then we have, thirdly, structural deterioration. This is typically caused by number 1 and number 2. However, sometimes you may have a very benign system that has very little hydrogen sulfide and not very much inflow and infiltration, but over time it still breaks down. So this might be an example, a city that has manholes that are 50 or 60 years old, and even though the conditions may be fairly benign, they're still in need of structural rebuild. However, typically we find that most manhole underground structures are actually affected by a combination of all of the above. So let's move along. Some of the typical generic rehabilitation options that most of you or some of you may have come across, I'm going to list really quickly. There are many rehabilitation systems available today. Most of them are coatings or single applications. The first one we typically find, one of the most common and probably the very first type of rehabilitation solution, is cementitious rebuilding or relining. We have different types of cementitious products, namely we have basic Portland cement mortar rebuild, and then we have some of the more sophisticated modified ones. For example, calcium aluminate infused mortars that improve the chemical resistance and improve the permeability to some extent to make the rehabilitation using a mortar system more successful. We have epoxies, is the second one. Epoxies, we have liquid epoxies that can be brushed, rolled, or troweled on. And then we also have trowel-applied structural epoxies, some of which have aggregates in them, some of them have fillers, nylon fillers, mesh, etc. We then have some polyureas. Some of you have come across these. You get the structural type polyureas and the flexible kind of polyureas. We have cured in place solutions. You get inserts, HDP inserts, PVC inserts, fiberglass inserts, very similar to the cured in place in some cases. And then of course we have replacement. Very often when people are talking about rehabilitation of structures, replacement is always one of the options being considered as a comparison when we're talking about cost-benefit analysis. So then people always ask me, which system is the best to rehabilitate my particular structure? And I always say that there is no simple answer. All the coatings or the systems I just mentioned above are excellent. They're very good for what they're intended to be used for. Okay, if they are used in the right manner, in the right environment, they're all very good coatings and very good systems. However, they have to be picked carefully and used in the right area for them to be at their most successful. So let's move along. That takes us to poll question number 2. What is the primary form of corrosion experienced in your system? Now that we've learned a little bit about corrosion, why don't you let us know? Do you typically experience mostly inflow and infiltration, hydrogen sulphide buildup, structural deterioration, perhaps a combination? Or if your city has no manholes in it, then this would not be applicable. Okay. Let's look at some of the other factors that would influence a rehabilitation selection, a type of rehabilitation selection. First of all, we always have to look at budget constraints. We all know that we probably would all like the best possible rehabilitation solution, regardless of the expense. However, sometimes the budget does not allow for this. So we have to make sure that we have the right product that meets the budget for the particular project in mind. We have to look at the life expectancy. Okay, we have to amortize the cost of the rehabilitation over the life expectancy of the project. If we have a system that we know is only going to be in place for, let's say, 3 years, I know this sounds unusual, but sometimes we have a client who comes to us and says, Dimitri, I have a manhole. This manhole is going to be replaced in 3 years because we're building a state park over here and we're no longer going to be running this entire line. But I need to focus on rehabilitating this for the next 3 years. Well, that'll be a different proposition to a manhole that we know is going to be there for the next 20 or 30 years. So we have to look at the cost over the life of the project. Then next we have to look at some environmental factors. There's a lot of areas in the country that, for example, don't like using coal tar anymore. That's one of the systems I'm going to discuss with you in a little while. Because it has solvents, it has some potential leaching into the environment. There's some areas that require 100% solids only. So these are factors we have to consider when selecting and or recommending a system for rehabilitation. And then the last one is the approval process. A lot of times I may get a maintenance manager coming to me and saying, Dimitri, I'd love to use your 100% solids trialable epoxy. However, it has not quite yet been approved by an engineering system. So at that point, it cannot be used. We may have to opt for something a little different, like a cementitious or a calcium aluminate that has already been approved by the system for use. Okay, let's move along. At Epoxy Tech, what we realized was that with all these complex solutions out there, with all these corrosion problems, different needs, it was sometimes a little confusing as to what type of system or product should be used. What we decided was, instead of offering people a product, use a roll-on epoxy, use a calcium aluminum mortar, we felt it might be easier to categorize the rehabilitation in the form of systems. So we came up with with 4 systems that we thought would pretty much cover the gamut of most of the requirements out there in the market. So if we start with system number 1, structural epoxy. This is 100% solids, trowelable, 16,000 psi compressive strength, single coat epoxy system. Let's look at composite system number 2, or system number 2. This is an epoxy composite system where we have a sewer grade mortar that's top-coated by a urethane-modified liquid epoxy. It can be brushed, rolled, or sprayed on over the mortar, cementitious mortar rebuild. Then we have number 3, which is a calcium aluminate system. The calcium aluminate system, as I mentioned before, is a calcium aluminate infused Portland cement system. This offers a much better chemical resistance and permeability than a traditional mortar type system and gives you a structural rebuild. And then number 4, our bitumastic system, which is also known in the industry as a coal tar. Coal tars have fallen out of favor a little bit, but they still do have their place. This is a product that has some solvent in it, and we typically recommend it as a liner, either on its own or with a cementitious rebuild to go along with it. So let's move on. Now let's look at each one of these systems in a little more detail. Firstly, we have the structure of the epoxy system. Okay, as we can see, if we go down the list of all the criteria that are listed on the far left side, let's high spot a few of them. The structural epoxy system is an excellent deterrent to inflow and infiltration. It's repairable, which means the system can be maintained and repaired over time. It has very good moisture tolerance, which means, as we all know, in these underground structures, it's almost impossible to get a perfectly dry substrate on which to apply your liner. This tolerable epoxy bridges that gap of concern when moisture does still exist in the system. We have a plethora of third-party testing on this kind of product. It's tested by the EPA, ETV. It's got SIGMAT testing. It is 100% solids, and therefore passes the green test without any solvents or anything of that sort that may otherwise not be accepted. And it is eligible for approximately a 10-year warranty when it is applied by a certified trained applicator. Pricing-wise, as we can see over there on that sheet, we're looking at about $7.50 per square foot for application material only, of course. Or in terms of linear foot on a 4-foot manhole, we're looking at about $95 per vertical foot. Okay, so that was our structural epoxy system. Now let's look at our epoxy composite system. Our epoxy composite system would be, as I mentioned, a sewer-grade mortar that's top-coated by our urethane-modified epoxy. This has some flexibility to it because the urethane modification gives us about a 38% elongation. It is pretty good for I&I prevention. Okay, it has excellent chemical resistance. Well, no, epoxies are pretty good, and once you add a urethane modification to it, it becomes even better. We do have some third-party testing on that product, namely the SIGMAT. We can call this a green product because we have 100% solids, no solvents, no VOCs. And with a certified applicator, we're looking at about a 3-year warranty on this product. Price-wise, we're looking at about a 1/4 inch of mortar with the urethane modified epoxy top coat, about $5.60 per square foot, or vertical feet, we're talking about $70 per vertical foot for material. So let's go to number 3 now, our calcium aluminate system. Calcium aluminate, as I mentioned before, is essentially a calcium aluminate infused mortar system. It does give us a structural rebuild. Not very good for sealing I&I, folks. I know that it's probably a lot better than traditional lower PSI compressive strength mortar. However, it still is porous. So ultimately, the water would still find its way through into the structure. Chemical corrosion resistance, again, slightly better than Portland cement, but still porous. The porosity results in bacterial buildup, which causes the breakdown from the hydrogen sulfide. This is eligible for a 1-year warranty and can be applied. Material price on application is at about a 1/2 inch build, which is what's recommended, is about $4.60 per square foot, or about $56 in material per vertical foot on a 4-foot manhole. Okay, so that takes us to system number 4. The bitumastic system, or as I mentioned earlier on, this is also known as the coal tar epoxy. Coal tar epoxies, as I mentioned, have fallen out of favor in a lot of places, understandably so. However, we still carry it because it is still requested and specified by many places. Let's go through a couple of the items here. It's fairly good on repair and maintenance. It has fairly decent chemical resistance because it lacks porosity. So again, it's a sealed system. Again, this one cannot be classified as a green product. In fact, there's a lot of places in the country where they're actually removing all the coal tar and replacing it with 100% solids, or having it top coated or sealed off to prevent any contamination in the system. The price of this is approximately $38 per vertical foot with an underlayment of about 1/4 inch of sewer-grade mortar. And again, that's for labor only on approximately a 4-foot manhole. So before we move on, what I would like to do is just go through each one of these 4 systems one more time and give you, as I mentioned before, a real-life example of where each one of these systems would be applicable for use. So let's start at the other end for a change. Let's start with number 4. If we look at a coal tar epoxy system, what we typically find is a lot of new concrete manhole structures that are being installed are often pre-coated, particularly outside, with something like a coal tar epoxy before they're buried in the ground and installed. Okay, we're not that crazy about this coating because, as you can see, compared to some of the others, it doesn't have quite the elements that you would like with regards to technical specification. However, I always tell people, if you have the option of not coating at all or using a coal tar, you're better off using a coal tar than nothing. That's, of course, unless your district municipality doesn't allow for this kind of product to be used in the system. So this would be used in a situation where you have low budgetary amounts available, pre-coating new structures, and there's not too much issue with the specification of a solvent-based product. Let's look at number 3, the calcium aluminate system. Again, this would be a structural rebuild. If you have a structure that is in fairly bad condition because of long-term breakdown, however, you have fairly benign conditions with regards to water inflow infiltration and hydrogen sulfide. Let's say, for example, you're in a fairly mountainous region. Okay, in a mountainous region, you're less concerned about hydrogen sulfide because the gravity makes the water run a little quicker, so you don't have standing water, and you don't have a lot of inflow and infiltration because it happens to be a dry area, for example. That would be a situation where you could use a calcium aluminate system as a structural rebuilder. Now your structure becomes structurally sound again. You have a situation where it is no longer a structural hazard, and at the same time, you're protecting it somewhat from the other elements. Let's look at system number 2, or the epoxy composite system. A great example of a place we would apply a product like this would be somewhere, let's say, in California Central Valley, where you have dry conditions, fairly low lack of gravity, which causes, and the lack of gravity and the heat cause high hydrogen sulfide buildup, and you have seasonal rains where you do have a lot of hydrostatic pressure from time to time on a seasonal basis. This would be a great product for that type of application. It does very well with hydrogen sulfide, and it can handle hydrostatic pressure, particularly on a seasonal basis, as compared to, say, a permanent, complete, consistent basis. And now let's look at system number 1. This is the structural epoxy system. This one would be used in the most treacherous conditions. Okay, I always use Florida as the example. Florida became a training ground for a lot of our products, and it's actually good that it had, because if we can solve it here, we can pretty much solve it anywhere. We have the worst of a lot of things. We have no elevation, so we have almost zero gravity, which means that our sewers are stagnant, our water stands a lot, so we have very high hydrogen sulfide buildup in most of our structures. Adding to that, the heat throughout most of the year intensifies the hydrogen sulfide buildup, so we have very, very high parts per million hydrogen sulfide in our wastewater infrastructure system. Adding to that, okay, not only do we have high hydrogen sulfide buildup, one of the highest in the country, but we also have very high water inflow and infiltration, very high hydrostatic pressure on a pretty much permanent basis. We get a lot of rain in Florida. The state is very flat, and essentially most of it lies below sea level, so we have a very high water table, so we have a lot of groundwater, not to mention that we also have tidal water. So if we take, for example, the city of Hollywood in Florida, I often use this as an example of some of the worst conditions that we've ever found. We have very old infrastructure. A lot of it is still brick. We have water falling out between the bricks. We have water pouring in. We have very high hydrogen sulfide. Every time there's a tidal increase or tidal decrease, anytime the tide comes in or goes out, it increases the hydrostatic pressure on the structures. So we have very high levels of water infiltration, not only rainwater, but groundwater and tidal salt water, but then we also have very high levels of hydrogen sulfide. Okay, and we have structural deterioration, and so these need to be rebuilt. So that's where we have the worst kinds of conditions, and that's where we would typically recommend a product like Epoxytec CPP that will give you the biggest bang for your buck on a long-term rehabilitation system. Okay, we can move on. So that takes us to poll question number 3. When you're looking for a manhole rehabilitation solution, what is the most important influencing factor? Is it A, price, B, convenience, C, performance, D, the most economical over the long term, or E, not applicable? You can take a moment to answer that. Okay, with that, I think that ends my formal part of my presentation. At this point, I'd like to thank everyone again for being online. I apologize for the slight hiccup and technical difficulties. And at this point, I'd love to take some Q&A if anyone has any questions regarding the material that we've just discussed.
Okay, yeah, we have some questions come in, and we still have time. If you haven't submitted your question already, please feel free to go ahead and submit them as we continue the question and answer session here. First of all, can you talk a little bit about flow bypassing? Do you recommend using flow bypassing when using these rehab methods?
These are good questions. A lot of it depends on a couple of factors. First and foremost, the different systems have different curing times. Okay, so that'll play a role. What we also got to determine is how aggressive the flow is during the application. Okay, I'll get to that in a second. And then also whether the specification calls for the channel to be lined or not. A lot of times you find a channel that is, example, has already got a PVC liner in it, in which case we probably would not line the channel, but rather line the bench tying into the channel. If we have a situation where the channel does not need to be lined and the flow is not too aggressive, we typically don't insist on bypass, because that way you can do the rehabilitation with less disruption to your wastewater processing. If the flow is much stronger, however, and or you have to line the channel, then obviously at that point bypass would be a requirement. Thank you.
Okay. A lot of questions regarding the slides, so I'll just address those now. The archived version of this webinar will be available online at trentusonline.com, probably within a day or two following today's presentation. So if you want to go back and review, you can view the presentation again at trentusonline.com. Anybody who registered for the event will get an email notification when that archived version is available. I'll back on to some more technical questions. What kind of surface preparation requirements do you have to ensure proper adhesion when using the epoxy products?
These are good questions. Each one of the 4-stem systems is a little different. If we take the structural epoxy system first, the structural epoxy system is very moisture tolerant. It can handle up to 100% moisture saturation in the concrete. We don't like running, dripping, or active water, but moisture saturation can be handled. So we typically recommend, because we don't need a specific profile, a water blast would be good, or hydroblasting, to get down to sound concrete or sound brick. At that point, the epoxy can be applied as soon as the running water has been removed. On the others, we're typically looking at the cementitious-based product. So what we do again want to do is get back to sound concrete, and then this is actually a little different, where when you're applying mortars, typically you actually like a little moisture in the existing substrate to get a better bond between the new and the old mortar tying.
Okay. A question here relating to testing. What testing requirements do you recommend? Are there any pull tests or strength tests?
These are good questions. We typically recommend a spark test, number one, to make sure that there are no holidays or pinholes in the coating, because those pinholes become isolated areas that get attacked aggressively that then cause the entire failure or system, for example, in a liquid-based epoxy system or a bitumastic-based system, to start failing. Okay, so a spark test will make sure that there are no pinholes in the coating and that we have a full monolithic lining. Over and above that, if there's any question about the actual integrity of the substrate under the coating, or the strength of the substrate, or the contamination of it, we typically would recommend a pull test, like a dolly pull-off test, to ensure that you're getting a high enough pull rate that will actually cause a cohesive strength failure in the concrete, rather than a delamination or a disbonding of the coating system. I hope that answers the question.
Okay, it's a question relating to the epoxy system. How does it work, or does it work in preventing root intrusion?
Yes, actually it works very well for root intrusion, for the simple reason that it does not allow water through. And we all know that the roots end up following the water. So this is not super duper so powerful that a root cannot get through it. I believe a root may be able to find its way through, but if the water is not getting through, the roots will not be following its way through. So it typically does a very good job of mitigating root intrusion.
Okay. Can you talk a little bit about the certification process that some of the contractors go through that are applying the product?
Yes, I'm glad you asked. Typically, the certification process, if an owner of a structure, for example, wants to specify that a warranty should be involved in the job. Let's say, for example, the structural epoxy system has been specified with a 5-year or a 10-year warranty that is to be issued by the applicator. What we would typically do is, at Epoxy Tech, what we do is we back the manufacturer or the applicator supplying material for any warranty work that needs to be done. In order for us to feel comfortable that the warranty can be serviced, we certify the applicators for the job, and what that typically involves is 2 things. Number one, we make sure that they have proper instruction and training on the handling, mixing, application, and storage of the material on a technical sense. And then number 2, we undergo inspection throughout the process to make sure that at all the stopping points, the important points of the application, all the right criteria have been met. That the surface prep has been met according to the specification, number one, that the product has been applied according to the specification, and then if there are any testing measures, for example, like a spark test or a pull-off test, and all those tests meet the specifications required by the engineering spec. If those things are all met, then we go ahead and certify the project and certify the applicator to then allow them to warranty the job.
Okay. Can you talk a little bit about what you mean by 100% solids epoxy?
100% solids basically means it has no VOCs or solvents in it. VOC, you know, the term itself can sound a little scary because there are some VOCs out there like solvents that can be hazardous, or isocyanides that can be hazardous to people that are doing the application. But it can also be something as benign as water, because water ultimately evaporates. A VOC is a volatile organic compound. When a product is 100% solid, what it essentially means is that the cure takes place chemically, usually by exotherm or exothermic reaction, which essentially means that it cures by itself without any evaporation required, and as a result you also get no shrinkage. So you have no volatiles coming off it that could be breathed in and could be hazardous, number one. And then number two, you have no shrinkage. So if you apply a product at a wet film thickness, for an example, of 50 mils, when it cures, it will still be 50 mils at dry film thickness. I hope that answers.
Are there similar products for pipeline rehabilitation work as compared to, or opposed to manhole rehabilitation work?
Yes, we actually have similar systems for pipeline rehabilitation too. Most of these products can actually be used in pipelines as well, obviously depending on what the pipeline's made of. However, these all would require man accessible. So if you have a, let's say, 72 inch diameter pipe, any one of these systems could be very well used within that pipe for the same kind of application.
Okay, you talked a little bit about the certification process. What about training programs that may be available for DIY type installations?
Oh, absolutely. What we also do is we understand that a lot of municipalities like to do some of their own work, particularly on a smaller scale, to do some of their own repairs and save money on their budgets. We do have a program that we talk to municipalities about. If they purchase the material, we have a program where we train them to, again, apply, store, and handle the product, and give them tips on how to do the application on site in order for them to do a more successful application to get the best out of the product. So we do have a training and application process or training program for municipal customers as well.
Okay, a question related to the warranty. What is included in the 10-year warranty, and what constitutes system failure that would require warranty action?
Those are good questions. Typically what we find is if we do have a warranty claim, what we would do is we would look at the application. If the application was totally done according to specification, which it would be if there was a warranty, more than likely, because we would have been on site to do the inspections. The warranty, as Epoxytec, we cover the material for the warranty. The contractor would pick up the labor portion of the warranty, and that would be anything from as small as a small isolated ding in the coating, all the way through to a full delamination, if it is found that it was not negligent use or anything extraordinary that caused the failure to occur.
Okay, a couple of questions here related to the performance of the material. One, if you have high groundwater pressure causing infiltration, how do you stop it, and how long would you expect the coating to resist the I&I?
That's a very good question. What we always tell people is there's a variety of ways for stopping an active leak. Typical methods include chemical grouts and then, of course, hydraulic cements. Now, we all know that those don't often last that long if the hydrostatic pressure is very high. So what we recommend people need to do is let's say, for example, they're using the 100% solid trialable epoxy system. That is one of the best systems for holding back inflow and infiltration and hydrostatic pressure. We always tell people you need to have the leak stopped long enough for the epoxy to cure. Once the epoxy cures, it will hold back the INI on its own. So typically we're talking about a window of 4 to 8 hours depending on the conditions. And once the epoxy is cured, it doesn't matter what's behind it. So if you can stop a leak with hydraulic cement for 8 hours, that's enough time for it to cure. Now, the second part of your question is the structural epoxy system does a very, very good job of holding back INI indefinitely. I mean, we've had structures in place for a couple of decades that have held up. So the reason why we offer 10-year warranties is because we're very comfortable that a 10-year minimum is pretty much standard with regards to being able to hold back inflow and infiltration, even in an area as aggressive as, say, Florida.
Okay, the other question related to the performance is in freeze-thaw cycles. Can you talk a little bit about how that stands up during the freeze-thaw cycles?
Good question. The urethane modified epoxy has a 38% elongation, so it does have a very good, handles freeze-thaw very, very well. The solid or structural epoxy system has a 6% elongation, which seems a little lower, obviously, than the 38. However, it is still an organic product, so it does breathe, move, and expand and contract with the conditions. So it actually, even though it seems rigid when you first see it, it's actually a very good, it handles freeze-thaw very, very well. We've had cycles where we've had systems, we've tested in-house even, sticking it in the freezer, taking it out, in the freezer, taking it out for, weeks on end, and had no issues with delamination or cracking or anything of that sort.
Okay. Are there any manufacturers that can apply the product before a shipment to a site? And, if so, what effect would this have on design life if factory installed?
Oh, a product's being applied before installation?
Yes, exactly.
Oh, like a pre-coating? Yeah, at this point we don't have any, let's say, manhole manufacturer that is using any of our products to pre-coat structures. This is something that we're big advocates of, not just because obviously we're an epoxy manufacturer or a coating manufacturer, but we always believe that the sooner you start maintaining your structures, the longer the life becomes almost exponentially. So if you pre-coat your systems early on, for example, let's say our urethane modified epoxy system. It is a repairable system. So if you were able to pre-coat your system or structure and put it in the ground before, or coat it before it goes in the ground, if you have a maintenance cycle every couple of years and you go back and do touch-ups, essentially you're maintaining a coating system, you're not maintaining the structure itself. The integrity of the structure over time will essentially remain unchanged.
Okay. A question related to some of the equipment needed. What is the typical construction footprint associated with these types of systems? Is there any large equipment that is required for installation?
Good question again. All of these products, can actually be applied with a very small construction footprint, to answer your question. Most of these products were originally developed for in-house, do-it-yourself use. Okay, so let's take the structural epoxy system. For example, what you would need is a drill, a trowel, and a bucket of water. So really, again, very small. Even the urethane modified epoxy can be sprayed, and we do have contractors that spray it. However, it can also be rolled or brushed. So again, we're talking about very small footprints. We started this initially because we thought that this would be very conducive for DIY, but we've subsequently found that even contractors, even on a large scale, do like the simplicity of a small technological footprint. They don't have to worry about machines going down. They don't have to worry about accessibility. We actually had some folks who, up in Portland, in the Portland area, Portland, Oregon, that lined a manhole on a lake. And they essentially took a small little boat out there, put a generator on the back, mixed up the CPP on the boat, and jumped into the manhole that was sticking out of the water and lined it. So the accessibility, because of the mobilization, was very easy. If they had to spray or do major resurfacing like that, it probably would have not been feasible for them to undergo that project.
Okay. As far as distributors and resellers of the product, how would somebody go about finding distributors, resellers, or applicators?
As of now, we are the only manufacturer, supplier, and distributor of the product based out of Florida. So we would be contacted directly. We do have a network of contractors that we currently work with, but we also have a training and certification program, as I mentioned before. So if there's a contractor in an area, if an application needs to be done in an area where we don't currently have a contractor, we could work with the local municipality, for example, to help train one of the contractors they already have a relationship with in order for them to get the application done correctly.
Okay. What is the recommended mill thickness for an epoxy system?
That's the structural epoxy trialable system. We typically recommend about 100 mils of application thickness. It's a trialable system. Of course, as long as you're making sure you have a good enough surface to trial 100 mils on. If the surface is rougher than that, you may need to either put on more or do a resurface before you do that. The urethane modified epoxy, which is the sprayable one or the brushable one or the rollable one, that we typically require 2 coats of 20 to 25 mils per coat, so we're looking at a total film thickness of about 50 mils, 40 to 50 mils.
Okay, there's a question here relating to the different types of materials that this can be compatible with. Do the products bond to different materials besides concrete, i.e. existing manhole PVC sheet lining, like a T-lock type of system?
We have found with CPP, particularly the structural epoxy, that it does bind to or adhere to just about everything out there. The only thing we have not been able to get it to bind to is HDPE. We always recommend, however, that people do a test patch to check first, because in most cases we have found we've had success with T-lock, with PVCs, with cured-in-place pipelining, fiberglass, etc. But once in a while we do come across some composites that do become tricky. So I always recommend people do a test, but for the most part it adheres very well to steel, it adheres to fiberglass, it adheres to most pipe lining systems. So in most cases you should be able to get a good seal around just about anything that you would typically find in a manhole.
Okay, there's a couple of questions here relating to residual H2S. Says after you've cleaned the walls of a manhole, there still could be residual H2S in the concrete, and how will this affect your coating system?
That's a good question. I mean, ideally what we want to tell you is you should get down to a pH of 7 before you coat. Now we know that's pretty much impossible in most underground structures. Most epoxies can handle fairly rugged, should we say, H2Ss. So you would be able to handle an H2S. It wouldn't affect the coating, put it that way. What we'd do is it would seal it off from getting any worse, and the residual that's left in there would not have any oxygen getting to it either, so it essentially the bacterial growth would stop. So you probably end up it would not get any worse.
Okay. Do you have standard specifications available for each of these systems?
Yes, we do.
Okay. And how would they could contact you to get those done?
Yes, absolutely. Just for while I have everyone online, anyone that attended today will be receiving an email from me in the next day or two with a little information about each one of these systems, and then also the ability to contact me for more detail and or a hard package if they so choose to.
Okay, here's a question related to the curing process. Is there a way to accelerate the curing process in situations where you've got close to water or tidal effects where you have a shortened window for the application?
Yes, actually most epoxies are temperature sensitive, so if the temperature is cool, they'll cure a little slower, and if it's warm, they'll cure a little faster. The urethane modified epoxy is a little bit sensitive with that, but as far as the structural one, the CPP goes, which is the structural epoxy tolerable system, that one can actually be accelerated. The cure can be accelerated in a number of ways. It can be accelerated really quickly by a simple direct application of a heat gun, for example, where we could probably get a section of epoxy to cure probably within an hour, as opposed to the typical 8 to 12 hour window, or running hot air through there. Let's say running hot air through the fan and the blower could probably speed that up to maybe 4 or 5 hours as opposed to 8 or 12. So there are ways of doing that.
Okay. Time for one more question here. Can you talk a little bit about the expansion properties of the materials and what effect they may have on installation or the final product?
The expansion? You mean expansion, yes. Contraction?
Yes.
Oh, during application?
I assume so. It just says
okay.
Expansion properties.
Okay, I'm sorry. Okay, essentially both of the epoxy products are 100% solids, and as I mentioned, one of the good things about 100% solids product is whatever thickness it is when you apply it, or whatever size it is, whatever volume it is, will not change during the curing process. So the cure itself will not affect expansion or contraction. So that answers part of the question. Now, if the question is a two-parter, as in expansion and contraction with free store, again, as I mentioned, it is organic, so it does free store a little, but it does move and breathe a little more than concrete does, but not to such an extent that you would have any sort of a delamination or any sort of movement that would cause the structure to be detached from the lining.
Okay. Well, that brings us about to the end of the hour here. There's a few questions we did not weren't able to get to, but we can address those offline following the presentation. So I would like to thank Dimitri Rapanis and Epoxy Tech for bringing us today's presentation, and hope you all found it worthwhile. And also want to thank everybody for joining us today. Again, a reminder, we will send an email to all of the registered attendees when that archived version is available online. We encourage you to go take a look at that again, and also take a look at the upcoming schedule for future trenchless technology webinars. So thanks again, everyone, and we look forward to seeing you at a future event.
Thank you very much.